Hey there, this is video C10, and we are going to look at the permutation formula. Even the last video, C9, I don't want to say it was getting annoying, but having to sit there 15 times 14 times 30, it's just crazy. Okay, there's got to be a better way. And yes, I'm going to show you how to do that today. All right, now answer this question. Think about it. Okay. How many ways can you arrange 52 cards in a deck? Or just the 52 cards, and you're going to lay them out in a line on a big table. How many choices do you have to make? Yeah, I'd have to make 52 choices. 1, 2, 3. Notice that's why it said explain. I didn't say actually do it. I just said explain. 52 blanks. And when I go to put down the first card, there's 52 choices. And then when I go to put the second card, I don't have to take the one that's next on the deck. Not like that. I could pick something else. I could pick somewhere else in there. I could deal from the bottom. For this question, that's allowed. So there'd be 51, 50. Yeah, that's ugly. Right? If I have to do that on my calculator, 2 times 51, 50 times 49, and I have to keep going all the way until I get 1. You know what? Odds are I'm going to screw that up. And even if I get it right, I'm going to second guess myself and probably do it again anyway. So you already know one cheat for doing this. That is the factorial button. So cheat number 1. Okay. Basically, the problem with this question, it's going to take too long. So we can do 52. I know I'm getting ahead of myself, but it just makes our lives easier if I show you how to do it. So 52 factorial. Look at that. How fast was that? And I know it's right, and I don't have to sit there and go 2 times 51 times 50 times 49 times 48 times 47 times 46, all that, because pretty much guaranteed I'll screw up in there somewhere. I'm going to go 8.07. I'm just rounding. Times 10, can't forget that part, to 67. That's a great big, huge number. So that's one way. Now, this factorial button only works, and just like in that last sheet, only works when you're arranging everything. So it's going to start at 52, and it's going to count all the way down to 1. However, if you're not doing all the elements, there is a formula, and that is right there. Okay. So here's our handy dandy formula. You want to memorize that. And frankly, the question, you probably want to write all of it out, because that is going to be just like when you're a kid doing spelling words and you would write them out 10 times, or you would write them in the air. I had a teacher that's write them in the air, kiddies. I don't know, but it kept us busy and out of trouble. All right, now it looks scary, but it's actually pretty sweet. This N and that N and that, they're all the same number, is the total. Okay, so the official formula. So this is a formula, is the number of permutations of n different objects taken r at the time. In English, for me, my translation. Okay, n is the total number of objects you have to pick from. So in this case, it'd be 52 cards. And r is the number you're actually using, the number you're actually picking. So in this case, it's going to be 52 also, because we arranged every single one of the 52 cards. So to start with, all I want you to do is go n is equal to r is equal to. Okay. So, how many ways can you arrange 7 different toys on a shelf? How many things do you have to work with? You probably should pause the video and, well, let's do the first one. We'll do the first 2, and then you do the rest. There's going to be 7 toys, and how many am I actually arranging? Well, I'm arranging all of them. So my N is 7 and my R is 7, and that's okay when they're the same. Okay, but let's look at this one. In a 7-horse race, how many first, second, and third place finishes are possible? Again, that's just me reminding myself I need to fix this. All right, so how many things do I have to arrange? Oh, sorry. Is the total of total N is the total number of objects you have to pick from. So how many horses are in the race? 7. And how many do I actually have to, do I care about? How many do I have to arrange or pay attention to? 3, first, second, and third. Okay, so what I want you to do now is pause the video and fill in the N and R for those last 3 questions. All right, how many 5-digit numbers can be formed by selecting digits from 1 to 9? Well, how many do I have to pick from? There's 9 things. With permutations, you can think of whatever you're given as being either physical objects or written on slips of paper, because there's no repetitions allowed. So that's how many I have to deal with. And how many do I need to arrange? That's where this part comes in. It's 5. Okay, how many 3 letters, arrangements of 3 letters of the word Friday can be made? Well, there's 1, 2, 3, 4, 5, 6 letters in the word Friday. And we have to arrange 3. So far is 3. Now, in how many ways might 10 runners finish a 10K race? How many things are we arranging? We already talked about this question. 15. Now, don't get messed up. That part about it's a 10K race, that's in there to mess you up, because that really has absolutely nothing to do with the question. Not particularly, not the math. There's 15 people in the race, and we need to pay attention to all 15 when they run through. All right, so the loop. R can never be the bigger one. If you put it in backwards, your formula gets all messed up anyway, or your calculator just says error, and it's not going to matter. It's not a huge deal, but just know if you're not sure, N is going to be the bigger of the 2 numbers. So for example, if you have only, let's say, this 7-horse race, okay? There's 7 horses racing. You can't have placement for the first 10 horses, because you're going to get through 7 and then you're going to go, who's going to go in 8, 9, and 10? There's nobody left, right? So N is always going to be the bigger of the 2. And here, I talk about factorial finally, which I think I've talked about for the last 4 videos. In math, it means factorial. And it's a shorthand for, I'm going to write special multiplication. It's not just multiplication in general. It is multiplication starting at the number and going down. So again, 6 factorial means 6, 5, 4, 3, 2, 1. And I think that's 720, but I'm not sure. I'll use my calculator. Oh, yes. You do this, you teach this long enough, you remember these. All right, so 10 factorial. And even if you have the 3 or the cheapy calculators, scientific calculators from the dollar store, they all have that factorial button on them. Okay. You want to get at least that for a calculator. What you really want, see down here, is you want one that has an NCR and an NPR. It'll make your life so much easier, and we will talk about that in a minute. I like in the next video. Anyway, 10 factorial is 3, 6, 2, 8, 8, 0, 0. Yeah, that'd be the same as me going 10 times 9 times 8. I get exactly the same answer, and it's just so much easier to use the cofactorial. So 4 factorial is going to be 4 times 3 times 1. So it's always where you start, and you just multiply down until you hit 1. 12 is going to be 24. And this part, 0 factorial is 1. It's the only way the questions make sense. It's kind of like the definition that 1 is not, I didn't know this, 1 is not considered to be a prime number. Because if it is, then a whole bunch of formulas don't work. So they said, no, 1's not prime. We'll just start at 2. Mathematicians get to do that, and we just follow along the rules. Okay, that I hope was a short and sweet video. I know we still didn't use this, but we did talk about factorial down at the bottom. So I think in the next one, we are going to use the formula.